Hey, welcome back. So I'm going to give you I'm going to work another balanced chemical equation with you. This is ethane, and again, it burns in the presence of oxygen and forms carbon dioxide and water. I'm going to show you a couple of different ways we can balance this. So one way is just to do it as we did before, count the number of atoms of carbon, hydrogen, and oxygen on the left and compare to the right. And let's see, 2 carbons, 6 hydrogens, 2 oxygens, and then 1, 2, 3 on the right-hand side. And then we get to change coefficients here in order to make things match up. So for instance, we can change the CO2 coefficient to a 2, and that gives us 2 carbons. That now gives us, let's see, 1, 2, 3, 4, 5 oxygens. So we need to change that below to a 5. We got 6 hydrogens on the left. If we have 3 waters, that will give us 6 hydrogens on the right. Our oxygens, we got 2 times 2, that's 4. 3 times 1 is 3, 4 and 3 is 7. So here is where opinions differ. So we've got more oxygens on the right, so clearly we need to add more on the left. Oxygens come 2 at a time, so 1 oxygen would be 2, 2 oxygens would be 4, 3 oxygens would be 6. 3.5 oxygens would be 7. So one school of thought says you can just have 3 and 1/2 oxygens there, and 3.5 pairs is 3.5 times 2, that is 7, and that is a balanced chemical equation. So I would say it is totally fine to use fractions. Some people don't like this, and the reason some people don't like this is they think that the coefficients are the actual number of molecules, but we'll see later it's actually the ratio of molecules. So there's really no problem at all having fractional ratios. In the same way that for every one arm on your body, you probably have half a head. Now, of course, you can't actually have half a head, but the ratio can be 1 arm to half a head, or 2 arms to 1 head, or 4 arms to 2 heads, no problem at all. So some people say, well, halves don't make sense. And if you're one of the people who says halves don't make sense, that is totally fine. What you can do is you can actually just multiply this whole shebang by 2. You can multiply it by 4 or 6, but the smallest way to get rid of the fraction is just to multiply by the denominator, the number on the bottom. And that changes that to 2 C2H6s. Remember, there's an implied 1 in front of everything there, so C2H6 didn't have a number in front of it, but that number was actually 1. We're just too lazy to write it. And we double 3.5, we get 7 O2s, and that turns into 2 times 2, that's 4 CO2s, and a grand total of 6 waters. So that is also another way to balance it. In fact, this equation down here is balanced using the lowest set of whole number coefficients. And the reason I think it doesn't really matter, but the reason I think it's important to discuss anyway, is that sometimes on multiple choice questions, it will say, if you balance this equation, what is the coefficient in front of oxygen? And of course, there's more than one answer. It could be 3.5, it could be 7. You could balance it a number of different ways. It could be 10.5 even, and you could possibly balance it like that. But there's only one lowest set of whole number coefficients. So when you use the lowest set of whole numbers, so that is you don't allow fractions, the lowest set is 2 to 7 to 4 to 6. And so then you could actually say, using the lowest set of whole number coefficients, the oxygen has a coefficient of 7 written in front of it. So I think it's worth knowing that. I don't get too head up about it. I actually like fractions. I think fractions are cool. It's kind of neat to do something that is sort of forbidden fruit, right? If you've had chemistry before, you may have heard you can't use fractions, but it is totally hunky-dory. It is totally fine, and it's fun. But on a multiple choice exam, they'll often say it this way just to make sure there's just one answer.